Imagine this. A force from space, just immense, flattens a forest bigger than London, but leaves, well, no hole in the ground.
Yeah, it sounds like something out of fiction, doesn't it?
Exactly. But it happened. Siberia, 1908, the Tunguska Event, one of Earth's biggest ongoing mysteries.
A total cosmic puzzle, and it unfolded miles from anywhere, which just added to the confusion for years. Scientists were really scratching their heads.
Absolutely. So in this deep dive, we're going to look at the sheer scale of it, the blast itself, and then tackle that huge question. Why no crater?
Right. And we'll sift through the theories, too. There's this sort of accepted science, but also some wilder ideas out there.
We've pulled together what we can from historical accounts, the scientific reports, different hypotheses, trying to piece together what the sources tell us about this whole thing.
Okay, let's do it. Let's jump back to that morning, the day the sky fell, basically.
Right. So picture this. June 30th, 1908, about 7:17 a.m. local time, way out in the Siberian taiga, near the Podkamenaya Tunguska River. Super remote. Hardly anyone lived there.
Which is why it took so long to investigate properly. But there were witnesses, indigenous even people, some Russian settlers, maybe even people on the Trans-Siberian Railway further away.
And their accounts are chilling. Many saw this incredibly bright light crossing the sky.
Yeah, described as bluish-white, almost as bright as the sun. Some said it looked like a pipe or a cylinder moving downwards, leaving this trail behind it.
And for those closer, they reported a huge flash, then this billowing cloud forming, and even a pillar of fire. A really intense sight.
And then the sound and the shock wave, just unbelievable. People described a deafening roar, loud knocking sounds like artillery fire, maybe.
Or rumbling, even an underground rattle, like dozens of trains going past all at once. That's how some put it.
And the force of that shock wave, immense. Witnesses hundreds of kilometers away were knocked flat on their backs.
Yeah, windows shattered far away, buildings shook like crazy. People felt this intense heat. One guy literally said it felt like his shirt was on fire.
Wow. Others reported being thrown meters, seeing trees just snap and fall, branches catching fire instantly, and that detail about seeing a second sun appear just before the main blast.
It paints such a vivid picture of chaos. And this wasn't just local. The blast registered, globally.
Exactly. Seismic stations all across Eurasia picked up the tremors and the air waves, the actual pressure wave from the explosion. They detected that as far off as the UK. Even Batavia, that's Jakarta now in Washington, D.C.
Incredible. What kind of earthquake equivalent are we talking?
The estimate is around a magnitude 5.0, so a significant shake.
And then there were those weird atmospheric effects afterwards, right? That adds another layer.
Oh, yeah. This is fascinating. For several nights after the event, right across Europe and Asia, the night sky just glowed. An eerie brightness.
Not just a faint glow either.
No. It was bright enough that people in places like Scotland and Sweden could apparently take photos at midnight without a flash. You can imagine how weird that must have seemed.
Definitely. What was the thinking behind that?
Well, the main theory is that dust, or maybe ice particles from the object, got thrown way up high into the atmosphere. And they scattered sunlight long after the sun had actually set below the horizon. It's a phenomenon they actually saw reproduced years later by space shuttle launches leaving similar trails high up.
That really drives home the scale, doesn't it? An event in remote Siberia affecting the night sky over London.
Absolutely. So clearly a massive, very unusual event, but investigating it, that was a whole other challenge.
Yeah, you mentioned the remoteness, which is obvious, but also Russia at the time, politically, it was chaos, the revolution, civil war.
Exactly. All that upheaval meant the first proper scientific team didn't actually reach the site until 1927. That's nearly 20 years later.
Wow, 20 years. Who led that expedition?
A Russian mineralogist named Leonid Kulik. He'd done some initial surveys back in 1921 based on local stories. He was pretty convinced he was going to find a giant meteorite crater.
That makes sense. Big explosion must be a big impact crater, standard thinking.
But what he found was, well, not that. Not at all.
No crater.
No big impact crater, no. Instead, what Kulik discovered was this enormous area, something like 80 million trees just flattened, wiped out.
80 million.
Right.
How big an area are we talking?
Over 2,150 square kilometers. That's about 830 square miles of forest, just gone, knocked over.
Just incredible. And the way they fell told a story, didn't it? It wasn't random.
Not at all. The trees were flattened in this very distinct radial pattern, like spokes on a wheel, all pointing away from a central point.
Okay, that suggests something exploding above ground, right? Like a bomb blast pattern.
Precisely. And here's the really weird detail. Right at that central point, the ground zero. The trees weren't flattened.
They were still standing.
They were standing, yes, but completely stripped bare of all their branches, just trunks sticking up. People describe them looking like telegraph poles.
Okay, so those two things together, the radial blast pattern pointing outwards and those weird standing trees in the middle, plus no crater that immediately told scientists this wasn't a simple rock hitting the ground.
Exactly. That's what made Tunguska such a deep mystery right from the start. It contradicted the standard meteorite impact model. This was something different.
So if it wasn't an impact but an airburst, how much energy are we talking about? Must have been huge.
Immense. Estimates have varied quite a bit over the years because it's hard to calculate perfectly from just the damage. Early figures ranged from maybe 3 megatons up to even 50 megatons of TNT equivalent.
Wow, 50's massive.
Yeah, though commonly cited figures are more around 10 to 15 megatons. Some more recent studies, using data from things like the Chelyabinsk meteor in 2013, suggest it might be more in the 3 to 5 megaton range, or perhaps 10 to 30. There's still some debate.
Okay, but even at the lower end, say 10, 15 megatons, put that in perspective for us.
Right. 15 megatons is roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima or the Trinity test bomb.
1,000 times.
Yeah. It's comparable to some of the really big Cold War hydrogen bomb tests, like Castle Bravo, maybe about a third the size of the Tsar Bomba, the biggest ever tested.
So if something like that happened over a major city today,
Total devastation. Absolutely catastrophic. It underscores the power involved here.
did later investigations turn up anything else? Kulik kept looking, right?
He did. He thought some small, swampy ponds, these pothole bogs, might be tiny craters from fragments, but nope. Turned out they were just natural features. They did aerial surveys later, in the 30s, which really helped map out that whole damage pattern clearly. Although, unfortunately, the original photo negatives were apparently lost in a fire later on. Only the prints survived.
Oh, that's a shame. But what about actual pieces of whatever exploded? Did they ever find anything?
Yes, but not big chunks. That's key. In the 1950s and 60s, expeditions found these microscopic spheres, tiny little balls of silicate and magnetite embedded in the soil and even in tree resin from the time.
Microscopic spheres. Are they significant?
Very, because analysis showed they had high nickel content, sometimes mixed with iron, in ratios typical of extraterrestrial materials like meteorites. And they found them concentrated in the blast area, kind of like fallout you'd expect from something disintegrating high up. Later studies found other unusual metal ratios, and even recent analyses, like in 2013, on microsamples, seem to back up an extraterrestrial source for this stuff.
What about digging down? Did they find anything in the soil layers, like in those peat bogs?
Yeah, that's another interesting angle. Core samples from peat bogs in the blast zone showed some weird things in the layer dating to 1908.
Like what?
Anomalous isotopic signatures for elements like carbon, hydrogen, nitrogen. Think of isotopes as like different weights of the same element, giving a kind of chemical fingerprint. These fingerprints were different in the 1908 layer compared to layers before or after, or in bogs outside the blast zone.
Suggesting something unusual was deposited then.
Possibly. Some studies also reported finding higher levels of iridium in that 1908 layer. Iridium is much rarer on Earth's surface than in asteroids or comets.
Okay, so maybe fallout.
That was the idea. Perhaps linked to acid rain formed by the explosion's interaction with the atmosphere. But it's important to say not all studies have been able to replicate these peat bog findings consistently. It's tricky work analyzing faint traces from over a century ago.
Right, scientific debate continues. And there was also talk about a specific boulder, wasn't there? John Stone.
Ah, yes. Some people suggested it might be a large fragment that survived, but the geological evidence points pretty strongly to it just being a local rock, unrelated to the 1908 event.
Okay, so summing up the physical evidence. Massive aerial blast, no big crater, radial tree fall, standing trees at the center, and microscopic extraterrestrial particles found later.
That's a good summary.
So given all that, what's the main scientific explanation today?
The overwhelming scientific consensus points to a meteor airburst. The basic idea is a cosmic body, an asteroid or a comet fragment, hits the atmosphere at incredible speed. The pressure and heat build up so fast and so intensely that the object breaks apart and explodes before it hits the ground, high up.
Creating that massive shockwave we talked about.
Exactly. A powerful airburst that does all the damage on the surface, flattening trees, causing heat effects, but without leaving a traditional impact crater because nothing substantial actually hit the ground intact.
Okay, that makes sense with the evidence. But the big question remains, what exploded? Was it rock or was it ice? Asteroid or comet?
And that is precisely where the main scientific debate still lies. The leading hypothesis within the airburst model favors a stony asteroid.
How big are we talking?
Estimates vary, maybe 50 to 100 meters across. Some newer models maybe put it closer to 50, 80 meters. An object like that, exploding maybe 5 to 14 kilometers up, seems to fit the blast pattern and energy release pretty well.
But hang on, if it was a stony asteroid, a big chunk of rock, wouldn't some bits survive? Why no fragments? Why no crater? That was the original puzzle.
That's the main challenge for the pure stony asteroid idea, yeah. It requires the object to have disintegrated almost completely. But, the Chelyabinsk event in 2013 really helped here.
How so?
Chelyabinsk was a stony asteroid airburst, much smaller than Tunguska, but it gave scientists real, modern data on how these things break up. That data makes it seem more plausible that a larger stony body could indeed disintegrate very thoroughly high up.
I see. So Chelyabinsk provided a sort of model.
In a way, yes. Though there are other ideas, too, like a recent one from 2020 suggesting maybe a large iron asteroid just grazed the atmosphere, caused the shockwave, and then skipped back out into space. A glancing blow.
Interesting. But what about the comet theory? That seemed popular for a while, right? Because comets are mostly ice and dust.
Exactly. The comet fragment hypothesis has the advantage of easily explaining the lack of fragments. A big ball of dirty ice hitting the atmosphere would essentially vaporize. Boof.
Makes sense.
This was definitely a favorite idea among many early Soviet scientists who investigated Tunguska. And remember those weird glowing nights across Europe that could fit with a comet? The idea being that fine dust and ice particles from the comet's tail or from the object itself breaking up got spread high in the atmosphere, causing those prolonged twilight glows. Similar to those space shuttle plume effects we mentioned.
Is there any specific comet linked to it?
Potentially, yes. The timing of the Tunguska event coincides with the Earth passing through the Beta Taurid meteor stream,
Which is debris from?
Comet Inc., and calculations of the Tunguska object's likely trajectory line up reasonably well with coming from that part of the sky. So it's plausible it was a chunk associated with Comet Inc.
Okay, so the comet idea explains the lack of fragments and maybe the sky glows. What are the arguments against it?
Well, some critics argue that a fragile comet entering at the estimated angle might have broken up much higher in the atmosphere, maybe not producing such a concentrated blast lower down. Also, those microscopic spheres they found, silicates and magnetite, that sounds more like rock than ice and dust.
Good point.
And some detailed modeling suggests the energy release and the specific way the trees fell might be better explained by a denser, perhaps asteroidal object penetrating deeper before exploding.
So it's still a bit of a tug-of-war between asteroid and comet, even within the airburst consensus.
Pretty much. The airburst of a stony body is probably the front-runner in the scientific community right now, especially with the insights from Chelyabinsk. But the evidence isn't absolutely conclusive. The comet possibility, or maybe something that was a mix, like a rubble pile with ice, it's still debated. It shows how science works, refining ideas as new evidence comes in.
And speaking of specific debates, there's that intriguing idea about Lake Checo. This small lake, not too far from the epicenter. Could that be the missing crater?
Yes, Lake Checo. This theory gained attention mainly from Italian researchers starting around the early 2000s. They proposed that maybe a smaller chunk, say 10 meters across, survived the main airburst and actually hit the ground, forming this lake.
What's the evidence for that?
Well, they did acoustic soundings, basically mapping the lake bottom with sound waves, and they found it has a kind of conical shape, which is unusual for lakes in that area, potentially suggesting an impact origin.
Okay.
They also did magnetic surveys, which hinted at something dense, maybe a rock fragment, buried under the mud at the deepest point.
Oh.
And they pointed out the lake's long axis seems to point back towards the explosion epicenter. Plus, their initial sediment analysis suggested the lake might have formed around 1908.
That sounds pretty convincing on the surface. A surviving fragment creating a small crater lake.
It does sound plausible, but like everything with Tunguska, there's a counter-argument.
Of course there is. What do other scientists say?
Other researchers, particularly Russian teams with long experience in the area, strongly dispute it. Their sediment dating, using things like radionuclide layers, which act like time markers, suggests the lake is actually much older, maybe at least 280 years old, possibly much more, which would obviously rule out a 1908 origin.
Right. A big difference in dating.
A very big difference. And they also raise points based on impact physics. They argue it's pretty unlikely that a fragment, after surviving that massive airburst explosion kilometers up, would still have enough speed left to punch out a crater like Lake Checo when it finally hit the ground.
So the physics might not work out for a secondary impact like that.
That's the argument. So Lake Checo remains this specific, fascinating point of contention. Is it the missing piece or just a coincidence? The evidence is interpreted very differently.
It really shows how complex this whole investigation is. Even something seemingly concrete like a lake can be part of the mystery.
Exactly. It's a perfect little microcosm of the larger Tunguska puzzle.
Now, given how weird the whole event was, this massive aerial blast, no crater, the lingering questions, it's probably not surprising that people started looking beyond space rocks, right? For other explanations.
Absolutely. When you have such a dramatic event with no immediate, obvious cause nailed down, speculation is bound to happen. While the cosmic airburst is the scientific mainstream view, other ideas have been floated.
Like what, any non-cosmic theories?
Well, one idea proposed fairly early on was a massive natural gas explosion, like a huge pocket of methane erupting from under the ground and igniting.
A giant underground burp, basically.
Sort of, yeah. Though it's hard to square that with the evidence for an explosion happening high above the ground and that very specific radial tree pattern. Other geophysical ideas have been mentioned too, things like a vernashot, a hypothetical rapid expulsion of volcanic gas from deep within the Earth.
But these don't really fit the evidence as well as the airburst.
Generally, no. They struggle to explain all the key features, especially the aerial nature of the blast and the potential extraterrestrial residues found.
And then
Yeah.
you get the really out there theories. The stuff of science fiction almost.
Inevitably. Because the event was so strange and unexplained for so long, it became fertile ground for speculation. You hear theories about an alien spaceship malfunctioning and exploding.
Right.
Or maybe a tiny black hole passing through the Earth. Or even, famously, that it was some kind of secret weapon test. Nikola Tesla's name often gets invoked there with talk of his experimental death ray.
Wow. So from natural gas to alien spaceships. Quite the range.
It is. And while those more speculative ideas are, fascinating to think about and great for storytelling,
There's no actual evidence.
there's really no credible scientific evidence to back them up, especially when compared to the cosmic airburst theory. The airburst fits the observed damage, the atmospheric effects, the microscopic evidence. It's by far the most robust explanation we have, even with the remaining questions about the object's exact nature.
So wrapping this up, Tunguska remains, even after more than a century, just this unparalleled scientific mystery, doesn't it? Still captivating.
It really is. The airburst of a cosmic object is definitely the leading explanation, but exactly what that object was, mostly rock, mostly ice, something in between, and specific details like the Lake Checo question, those are still actively debated and researched.
And thinking about the bigger picture, this whole deep dive into Tunguska really hammers home something important, doesn't it?
Absolutely. It's a stark historical reminder that Earth exists in a cosmic shooting gallery, basically. We are vulnerable to impacts from space.
Even from things that don't hit the ground directly, but explode above us with enormous force.
Exactly. Tunguska underscores why it's so vital to keep searching for and tracking near-Earth objects, asteroids, comets, and to think about planetary defense. How could we potentially deflect something heading our way?
The Chelyabinsk event in 2013 must have felt like a mini Tunguska moment for many people.
It really did. Much, much smaller, thankfully, but it was captured on dashcams seen by thousands. It brought that abstract risk of air bursts into very sharp modern focus for everyone, reinforcing the lessons from Tunguska.
So the Tunguska event showed us these incredible forces from space can interact with Earth in really surprising ways, leaving these puzzles that last for generations. It kind of makes you wonder, doesn't it? What other cosmic events, maybe even bigger or stranger, could be out there waiting? Or maybe hidden, undiscovered, in our own planet's deep past?